afternoon, good evening, and welcome to another episode.
Working on OpenShift
and sometimes we haven't.
This is so awesome.
Are an open culture that
it's actually
in
a big piece of the component for your GitOps work.
Everybody has something that they can say.
On top of the Red Hat portfolio.
Good morning, good afternoon, and good evening to everybody. The music you just heard means you stumbled into yet another level up hour where we discuss containers, Kubernetes, and OpenShift. My name is Randy Russell. I'm the Director of Certification at Red Hat, and I'm joined by my co-hosts, Jafar Shaibi and Scott McBrien. Please like, subscribe, share, let people know that we're here contemplating all the wonderfulness that is containers, Kubernetes, OpenShift. And so this is our first show of 2022. We made it back, and I'm looking forward to our show today and the shows to follow. We have a lot in store here in 2022. So with that in mind, greetings to those who are joining us again, and let's get into it a bit here. Scott, we're going to be talking about auto updating containers in Red Hat Enterprise Linux. So we're going to step away a little bit from OpenShift today, focus a little bit more on Red Hat Enterprise Linux. Jafar, this is your cue to nod, meaningfully. Yeah. So Scott, set us up here. What is the background of wanting to do this?
Sure. So in a lot of organizations that have made their transformational journey to containers, one of the big benefits to that is the speed of development, right? And so as you are making changes, you want those changes to propagate across your infrastructure so that you can have the newest stuff that is hot delivered to the end user. And so traditionally, we've used a variety of different technologies to try and accomplish that, from things like CI/CD pipelines to other stuff. But in the Red Hat Enterprise Linux world, we use Podman for this. And so in RHEL 8.4, we started shipping a newer version of Podman 3. something. And we included a Podman subcommand called auto update. And that's kind of what we're going to be taking a closer look at today. And essentially what it allows you to do is set a configuration option at the container level that says this one container you're interested in turning on auto updates for. And it ties into systemd for managing the redeployment and re-execution of containers. And it can also tie into systemd for the systemd timer units to do that on a schedule, right? So you can check it. By default, it's every day, but you can change it to every hour, or every second, or whatever you want by adjusting the timer configuration. And so it's a couple different Red Hat Enterprise Linux administration skills that come into play to really make this magic happen.
It sounds like the cron job of auto updating containers.
It is. In fact, we've kind of supplemented cron with the idea of systemd timer units.
Yeah.
Because systemd does all the things, so why not have it do cron as well?
Sure. So Jafar, what are your thoughts here so far? Is this a little bit out there that we're going to be doing these operations on containers outside of the lovely orchestrations of OpenShift?
So actually, that's a very interesting feature, because a few years ago, I believe it was 4 years ago, we had that conversation with one of our customers who was using RHEL and who was looking at OpenShift for managing containers at scale, but they had this sort of edge facilities where they wanted to run independent systems that were containerized. So they had already containerized some of their applications, but that factory didn't have the horsepower to run a complete OpenShift platform and they had, I believe, hundreds of small facilities around the place. So basically, we were looking to implement that, but we had to come up with ways of doing it that were manual and that were sort of workarounds, because we didn't have that type of capabilities. And so basically, it was something that we needed by then, because, for example, the CI/CD would kick off on the OpenShift platform centrally, but then we would want to push the new images to all the facilities, so they benefit from the updated version of the application. So I think that's a great feature that will make it much easier to implement that type of use cases. And I'm looking forward to seeing the demo and learning more about it, because it's not a feature that I had in mind. Actually.
It's one that you wished you had at one point.
Exactly.
And so actually, it kind of brings us full circle for a moment before we launch into some further discussion of it. Is the description of the use case that you just gave brings to mind one of our recent episodes where you're talking about single node OpenShift. And I just have to ask out of curiosity, might that have been an alternative solution to the use case you were dealing with?
You mean the single node OpenShift?
Yeah, that fairly recently released as an alternative to that particular use case you described.
So interestingly enough, that was the we were using OpenShift 3 by then. So I think we didn't have OpenShift 4 yet. And so we had the equivalent of single node OpenShift with OpenShift 3, which we used to call all-in-one. But still, they didn't have enough resources to have like the full Kubernetes orchestration, and they didn't want to have that because it seemed too complex for the use case where all they had to run was like 20 containers on a very small footprint machine. So even by that time, and even if we had OpenShift single node in OpenShift 3 version, it didn't really match their use case because of resource constraints, basically.
Okay.
And complexity of managing that. They didn't want to have like a Kubernetes expert needed on site to troubleshoot whatever happened. They just had like RHEL admins, and they didn't want to go to that next level, which is getting full speed into Kubernetes.
All right. Well, so that kind of sets it up really well, Scott, right? Because that's essentially what you're going to introduce to us today.
And across the Red Hat portfolio, there's kind of different shades of gray on managing containers, right? So what we're talking about today, I would classify as really basic automation, right? We're just going to like stamp this thing out. There's not a lot of logic involved in it. It's just after a certain amount of time, I'll check this thing. If it's newer, I'll pull it down and execute it. You can get more sophisticated automation if you throw in something like Ansible, right? Because they have ability to do some level of logic. And then if you want orchestration, which is not just the logic of deciding what to do, but also throws on like where it should be done and how it should be done and complex ordering of tasks to be done, especially in a situation where you have multiple containers reliant on each other. And maybe there's a very precise startup process that has to happen. Different things have to be exposed to the machine. That's where orchestration comes in, right? And Red Hat Enterprise Linux does not do orchestration, right? We even don't do a ton of automation, right? We do automation. We provide a framework for that, and you can use things like shell scripts or Ansible to give you that next level of programmatic automation. But if you want orchestration, if you want to monitor your deployments, you want to make sure the containers are running, and if not, start them up again or start them on a different node. Like all that stuff is Kubernetes and orchestration through OpenShift. So, and in fact, Jafar was talking about the edge. That's one of the places where we see this a lot because edge devices are not super beefy. Even single node OpenShift today, I believe, requires 8 processing cores.
Mhm.
Yeah, and 32 gigs of RAM.
Yeah, and so if you're talking about like an Intel NUC, you could do it there if you buy the highest end one that you can get. But a lot of the PCs of that or computers of that form factor are dual or quad core, single processor. That's pretty much it. And then RAM is another one where they struggle to get large enough to be able to run single node OpenShift to get you that orchestration component. But that said, a lot of the use cases, they don't need that because they're not running really complex workloads on those things. They're running 5 containers, 10 containers. They tend to be designed to be more independent. So it's okay to just use not very sophisticated automation to apply updates and manage those boxes.
What sort of decision process would an organization, a team, go through to sort of arrive at that conclusion that this might be the way to go, and that something more involved and to get into full orchestration might be overkill? What's sort of the thought process, or what's the checklist, or what are the kinds of things that somebody should go through and say, okay, yes, this, or no, or whatever the case might be, that would help them decide this is the way to go, as opposed to a more fully orchestrated approach?
So that's a tough question, because if you ask Jafar,
That's why I asked it.
OpenShift. Oh, I'm sorry. I thought you were talking to both of us.
I am.
Yeah. So if you ask Jafar, it's going to be OpenShift. If you ask me, it's going to be RHEL. And I think that there's a bunch of white space in between where either one could be the correct choice or a valid choice.
Yeah, so I think that one of the things maybe to take into consideration is whether you need advanced scheduling capabilities and things like placement rules, where you have to. So, for instance, if you are speaking about one machine, then it's probably fine to just run with the Podman and all the primitives that comes with the RHEL. If you have 2 or more machines, and then you have to start guessing where it's better to place the container, it becomes a more complex problem to solve, because you have to implement basically all the logic to compare the available capacity, the required capacity, etc. And basically you are then rewriting Kubernetes or an orchestration.
Yeah, exactly. That's sort of the taper up and taper down is, do you find that you're actually rewriting the Kubernetes application independently?
Yeah.
Well, that might be an indication that you need to go OpenShift. But it does sound like there's actually some pretty clear use cases, particularly around edge, particularly around resource constraint. Let me ask one more question. Do you think this is the sort of thing that an organization that is OpenShift savvy would decide, well, okay, look, we know OpenShift, we do OpenShift, we're implementing it for this particular use case, we're making the choice not to do it? Or is this the sort of thing that we're going to see from an organization that hasn't even dipped its toe into OpenShift, regardless of the scale? Any sense of that? Either of you?
Yeah, I think both can coexist. I mean, you can have an enterprise that run OpenShift at large scale and still have some use cases where they are going to choose to go with that very low footprint RHEL containers on RAN pattern. So it's not necessarily something that it's not an or an XOR. It's not an exclusive or. They can be both valid for different types of needs. So yeah, of course, if you have no experience with OpenShift, it's probably easier to at least learn about containers by using Podman and doing things on single or laptops or single machines, etc. And once you get familiar with these things, then you get further away with new concepts like the orchestration and such things. So,
All right. Yeah. Well, so Scott, do you want to run us through a little bit of what the process is here, or is there?
Yeah, I just want to tag into one comment on our last thread of discussion, and then I'll shift into the demo.
By all means.
So I think there's a natural inclination for people to stick with what they know. So if you are a Red Hat Enterprise Linux organization, you have a lot of Red Hat Enterprise Linux expertise, that's probably where your feelings tell you should stay, right? And that may not be the right decision. If you are an OpenShift organization, you use OpenShift for all your containers, but now you're putting into a different class of hardware or a different method of deployment. Like, your feelings are going to tell you that you should stay with OpenShift because you've already got all of that like background and expertise and other stuff with it. But that may not be the best choice for you.
Your hardware might tell you something different than your feelings.
Right. And then there's like a ton of gray area in between. And I noticed in the chat, somebody talked about K3S. Red Hat does not have a supported K3S implementation. We either have Kubernetes or we have, automation with tools like Podman. And that's just because like how many things can we shove into that gray space to create even more confusion on which route someone should take when they're going through a deployment or learning a technology? How many more technologies do we want to heap onto them? So that was a very conscious choice on our part to not include that.
Yeah.
All right. So demo. Live demo.
Live demo? What could possibly go wrong?
Indeed. Okay.
But it's all going to be automated, so everything will be great, right?
So I think we'll have to ask for a jingle for the live demo.
That's right.
With Randy's vocals on
it.
All right.
Take note.
So just to kind of lay some groundwork here, this is a Red Hat Enterprise Linux system. It has Podman and some other tools installed, and I've gone ahead and pulled down an older UBI image. So you can see in this top of my images list, there's one that's tagged 8.5-200. That is old, right? And the reason I pulled it down as old is I wanted to be able to auto update to the latest, right? If you don't have something old, how do you get to the latest if you're already on the latest? So, and I'll go through towards the end on how I actually accomplished this, but you can see that there's another one in there tagged latest that has the same image ID. So essentially, I pulled down this old one, I cloned it and said it was really the latest one, so that the next time the system checks in the registry and sees that there is a newer UBI in the latest, it'll go ahead and pull it down as part of the auto update. Right? There are a couple other small things that I've done here, and again, I can go through that towards the end. But I want to jump in and show the critical parts, which is like, how do we actually set up auto updating? So I also want to mention that this is related to an article that is available in the Enable Sysadmin community, and I think our producer has already linked it into the chat. It was written by Dan Walsh and Preethi and a couple, I think one other author, and they base theirs off of Fedora containers, and we're basing ours off of the universal base image and the Red Hat registry for the freely distributable universal base image.
And if you are interested in the universal base image and you're not familiar with that subject, go back a few episodes in the Level Up Hour and you will find a meaningful discussion about said UBI.
Indeed.
Sure.
All right. So I have this image, and I'm going to create a container image out of it. And so I'm running this Podman create. I'm going to call my container my app container. And then here's the magic, right? This label IO containers auto update equals registry. So this special label is a configuration option that tells our system that when we run Podman auto update for this container, it should check with a registry to see if there's a newer update available. So there are two options that you can pass here. One is registry, which is what we're using. The other is local, which is I should look only in the local container repository for making this decision. So if you're applying an update locally, you can then run your production system off of that local registry and pull down the update.
So Scott, before you hit enter, is it a typo where you have sleep infinity?
No, that is not a typo. So
Infinity?
Yeah, in infinity. There's
Infinity.
sorry. Yes, that is.
Okay.
Jafar, come on. You need to have let him hit enter. Okay?
We don't have the jingle yet. When we have the jingle, I'll let him.
You'll let him wander into the minefield. Okay.
Yeah.
I literally copied and pasted this last night, so it does still work even with the typo. Maybe not as much as I wanted it to.
All right.
Maybe
so
that also.
It may not work now that we have removed the typo.
Yeah. Thanks for your help, Jafar.
You could possibly go wrong. So the other things are the base container image that my app container is now going to be based off of, right? So I'm telling it that we're going to take this my app container. It's going to be based off this UBI image in the image repository. And then the sleep infinity, that is the job, the command that will be executed within the container, right? So we're just going to sleep it and it's just going to run essentially and not do anything. But this could also be a starting up your web server or a variety of other things, right? All right, so let me go ahead and hit enter here, maybe. There we go. And if I do a podman, yes, -a, there's that new container that I created, right? It's based off of this UBI latest from my local repository. When we run it, it's going to run the command sleep infinity, and the name associated with this is my app container. All right. So now we've got our container created. It's tagged to do auto updates. And when Podman is called with auto update, it's going to check against our registry. All right. So at this point, I could run a command Podman auto update my app container, and it would execute that automation to check the registry and pull down a newer version if it existed. But we want to run this container, and not only do we want to run it, we want to automatically pull down the auto update and redeploy it. And so for that, we're going to have to mix in a little bit of systemd. So you may not know, but systemd allows regular users to have their own systemd units. So if you create a systemd directory structure in your local home directory, you can use these user-based systemd units. And I'm just going to create a systemd unit for my new container. Yes, Jafar.
Yeah, I was going to ask. So I see you have RHEL Web Console. Is that like the admin UI that we provide, or is it something?
It's a web-based UI that you can use, and there actually is a container management thing in there that's relatively front.
That's what I was going to say. I think you can also create systemd containers from that UI also, but
it's been a while since I've looked at it.
Yeah, it's Cockpit, right?
It is, but it's not the upstream Cockpit project.
Yeah. Okay. I mean,
console.
It's the web console we have with RHEL, right?
Right, correct. And that does change over time. Like when RHEL 8 was originally released, the container management there was not super complicated, and over time it has gotten much, much, much more fully featured. Last time I looked at it was about 6 months ago, and I was like, wow, that's really useful in a lot of things.
Yeah, I actually use it a lot on one of my RHEL instances. and
And so-
especially for those containers.
So
Yes,
just
Omar.
for my edification and clarification, we did our initial step, which put it into place forever because it's infinity. However, I'm assuming that after your first step, had you restarted your system, this would not be in place because it was done live on the running sort of system, and it would not be persistent. And the step that you are now about to take, that you're poised, your hand is twitching to hit enter, that this is now what's going to make that persistent across reboots and so on.
So kind of.
Ish.
So the
Ish.
actual my app container is persistent. I created
Okay.
it. It's out there in the local registry. It's there, but it's not running. Notice that when I did a Podman PS-A right here, it said that it was created, but it's not running. Right? It was just out there in the library essentially.
Yeah, yeah.
I haven't
It's
created-
available. It's available, but not running.
Correct. So if I rebooted the machine right now before hitting enter, that my app container image would still be in the local repository, but it has not yet been run, and after reboot would not automatically start up. It's just going to sit there in the image library. So what we're doing here with this Podman generate systemd is creating a service unit for this container, which will start the container. Well, I'll have to enable it using systemctl, just like I would a normal service. So I'll have to start up the service, and then thanks to that systemd unit and the systemd unit being enabled, it will then survive reboots. So if my machine reboots, it'll start up this container automatically. So that's where we're going. And then I just wanted to point out that this Podman generate systemd is super slick, because what it really did was create this my app container service unit, right, which looks like this. So just running that one Podman command made all your systemd stuff happen. And down here in the service section, this is what I think you were talking about, Randy, that
Okay, yeah.
when this unit is executed, it runs that container out of the container library. But like one command, the magic is happening.
Or you could just go and type all of that by hand. Fire up your favorite
Good.
editor if you have all day and nothing to do.
Well, and what are the likelihood that you would typo anything, especially during a live demo?
Well, given today's show, I'd say it's high
All right.
in Nifty.
A couple other small things because we're not rebooting. I'm going to reload or send a signal to the systemd daemon that it needs to reread its configs. Because I just dropped this new service file, but systemd that's running doesn't know about that service file yet because it doesn't have it in its cache. So the daemon reload has it cache that file, so now it's available. And then I'm going to go ahead and start it. And if I do a status, right, we could see that this container is executing. And if I wanted it to survive reboots, I'd also have to enable it so that at boot time it would start up. All right, so if I podman yes, right, there's my running container. It is running its sleep infinity there, started up. Status here is up 27 seconds ago, so it's actually executing. And
So pause for a moment. So
Yes.
Joe Brown asked the question, which I think you had touched upon earlier, but let's clarify it again, about no admin permission needed to add it to systemd. You've actually taken some steps within systemd and its user level capabilities, right? That's what sort of set the stage.
correct. So that's built in. Like I didn't change anything about this box. I didn't change anything about this user to grant them this permission. Like that's part of the systemd service is that users can create their own services within the context of their user, right? So I'm logged in as this unprivileged user named RHEL, and processes that I run through systemd as RHEL have all the rights and privileges of the RHEL user, right? So we talked also a while ago about rootless containers. That's what my app container is. It's running rootless. So all of the things that it may be doing inside of its container image is only allowed on the container host to operate with the rights and privileges of the RHEL unprivileged user account. And the same thing is true for the systemd services. Anything that I do as the RHEL user with systemd operates with the rights and privileges of the RHEL user and is not able to exceed those privileges and do root stuff.
Right. And so if we're talking about sort of not necessarily a live demo, but a production system in the field, very likely there would be some user created for the purpose of doing this and not running as a privileged root user, unless there was absolutely something that required that, right? That essentially it would be the same process, except it wouldn't be, Scott's user account. It would be an account created for this particular purpose. Would that be a safe statement?
It highly depends on the organization. So, for example, in the DoD world, you don't have service accounts. So you would not be allowed with security protocols to be able to create a generic user account for managing services without a lot of effort. So it depends.
It depends. Fair enough.
Yeah. All right. And so just to circle back on that Joe Brown's question there. So I just want to show you the couple things I did. Right. So the first thing was in my home directory, I made a directory under .config systemd called user. That's where my user control stuff goes. And then when I used my Podman generate to make that new unit file, notice that I stored it in this .config systemd user directory. Right. So the unit names are the same in the individual user configuration of systemd as they are for the systemd. Okay. So here we are. We're running our container. You can see here is its unique container image ID that goes along with it so we can track the viability of this guy. All right, so that's a lot of setup. And so what I'm going to do now is actually run the Podman auto update. And I'm going to pass it an option. So instead of actually doing the auto update and executing it, what I'm asking it to do is just show me the steps and the output that one would see if they were to auto update. All right, so the my app container has been flagged as an auto update container, and it went out to the registry and sees that there is a new container image available. And notice the updated status over here is pending, meaning we have not applied this update. So if I run Podman auto update without --dry run, it will pull down that updated container image from the registry. And thanks to my service, it will redeploy this container running on the system with that newer updated image. All right, you ready?
Yeah, go
Stand
ahead.
back. Hold my beer.
Exactly. Hold my beer. All right. So here it is pulling the updated base container image from the registry. All right, so that's good. It recognized that our container is based off an older base image. All right, and now when I do a Podman, yes, there's nothing running. Before it was running, but now it's not.
Is that what you automated?
So it pulled it down, it re-executed the update of the MyApp container, and then redeployed it. Right, and we can tell that that's the case because up here, the last time our MyApp container was running, look at its container ID. Right, the last four is Alpha 5 Delta Echo, and down here, the last four are 6 Foxtrot 8 Bravo. So it actually pulled down and made a new container image from that updated UBI and redeployed it so that we can see in our PS that it's a new image. In fact, you can see there's a difference in the runtime and a whole bunch of other properties that show us that this has actually happened. All right, so that's the magic. There's a lot of lead up for like one command.
Well, that's the essence of magic. If it was a whole lot of this, then it might not be so magical, right?
That's true. So maybe it was more science. The magic would have been if it just auto update and it just worked. All right. So we have this guy auto updating when you run the command. All right. So if I run this command again, goes out to the registry, sees that there's nothing newer, right? So it says updated false. And we didn't have to do anything. And if I look at my Podman APS, it did not redeploy this container because there was no update available. It's still running the same container it was running a while ago, and it will continue to do that. So that's how you can auto update by hand. And for some people, this might be where they stop. But we're not those people.
We're not those people.
We're not those people.
Oh, no. We have to forge on.
That's right. So the last thing that we're going to do is we're going to add a timer unit to this container so that we will check to see if there's an updated base container in the registry behind the scenes. And when we find that that's true, we'll go ahead and execute it and pull it down and redeploy it. So for that, another bit of
before you amaze and impress.
Yes.
What are the sort of considerations that somebody might undertake in terms of that timing? Is it you watch how frequently a particular image that you're using in a registry tends to update and try to set your timer to that, or is there a best practice around your timer interval, or is it just we're going to guess and see what happens?
So the default timer that I accidentally hit enter on will check every day. So we'll take a look at what the system timer is set to, but it'll check every day to see if that happens, and if so, it'll execute it.
So the default is check daily. Yes,
check daily, but you can override that. So you could make it check hourly or check secondly if you really wanted. I think the bigger thing is knowing whether you really want it to check automatedly and pull down and deploy that with automation.
Or whether you want to have a person making a conscious manual decision.
Yeah, so would you prefer to run some Ansible and contact your fleet and tell them to all auto update?
Oh, okay.
At a specific time, right? So you know that if things go cattywampus, you know exactly when that happened and exactly what occurred when things went belly up, and you can maybe reverse it. Or is something happening in the middle of the night across various systems in your organization the way you want to go? Right? It's certainly less effort because you don't do anything. You just sit back and things happen. But then in the morning or when the pager starts going off, you need to figure out that actually occurred, what systems it occurred on, when it occurred, and then you have to find it and roll it back. So I think those are the
grep for cattywampus in your logs, I guess.
Exactly.
So I have a crazy thought here, but I'm gonna go ahead with it. So imagine you have hundreds of containers, and the first thing, as soon as I say hundreds of containers, you're gonna say, okay, go ahead and use OpenShift or Kubernetes. Yeah, that's probably a valid answer. But imagine that you want to have a PubSub pattern, when the image is updated centrally, you push a notification to everyone who's interested in that, and that's when they do the update rather than polling the registry every 30 seconds, because when you implement that continuous polling, then it might overwhelm the central unit or the registry because you are doing HTTP requests on a specific interval, And of course, depending on the load, if you have like hundreds of thousands of containers running, it might be more complex to handle. But is there something like this that can be implemented? Like if you have a Kafka stream somewhere and your registry sends an event in the stream, and the Podman, when you say Podman auto update, it translates into you subscribe to the update event, and then you do that whenever you receive that update. Is it something that
So,
can make
so
sense?
Kafka, and I have no idea what I mean, I know it's a technology, but I have no idea what its capabilities are or how to interact with it. It sounds very OpenShifty to me.
Well, it's basically an event stream, an eventing, I would say, technology where you can basically trace all the events that you are interested in, and as a subscriber, you can say whenever this type of event gets written in the stream, then send me a notification.
So I'm sure that one could come up with something, right? Because with shell scripting and Ansible, like as much effort as you want to pour into it, you can get some output out of it. It's going to be effort to make those things happen. We keep things simple, right? Our technology, if it's broken, simply apply more hammer and it will fix. There's not a lot of complexity without the user putting in a lot of complexity, or the administrator setting this up, putting in complexity. But with complexity, you now have more complexity to maintain over time, right? So I'll leave that to an exercise for the user or the watcher of the show to decide what their organizational skill level is, how complex their environment is, to decide whether they want to invest in that or not. Or do they just go with something like OpenShift that has a lot of this complexity already built in, with management tools to make using that complexity easier, right? That's kind of the value prop there. All right. So the last thing I did here was put in the auto update timer, and I just wanted to tie that off. User. And so I'm just looking at the auto update timer that I created with this enable. It is using the system Podman auto update timer module or a unit. And when I cat it, this is the instructions, right? So it's going to do the on calendar daily. So it's a once daily check-in. The randomized delay sec is sometime between 0 seconds and 900 seconds from recognizing that it needs to do that every day. It'll do it. That's to keep all of your daily firing jobs from all happening at the exact same time. And then persistent is, if we reboot the machine or the machine was rebooted today, we should do that. So you can also put in your own customizations to override the system defaults if you would like, and that can go in your individual user systemd timer unit. So you could open this file in your local systemd configuration and add or change or override these parameters. But that's what's doing it every day now. So tomorrow when we come in, it will have checked, and I'm not expecting a UBI update tomorrow, but if there was one, it would go ahead and pull it down and redeploy it.
So, question, is there any sort of, within what we're doing here, is there any sort of concept of rollback?
So I know that the article that Stephanie posted earlier does cover the concept of rollback. I did not invest a bunch of time in like figuring out how to roll that into this demo. So yes, there is such a concept, but I didn't put in a bunch of time to figure out how it works or what types of logic one could put into place to determine whether you should roll back something or not.
Okay.
If I look,
So that's left as an exercise for the reader. Again, take a look at that article that our producer posted, and it seems to me like a logical next step if you're doing this sort of automation is to maybe have a plan in place for calling it back when things maybe don't go the way you want them to.
correct.
Well, so what else have we got, Scott? I'm asking people if they have any questions to post them in the chat, but are there some other things we want to share about this capability?
So the one thing that I did to get this whole thing started, you may recall that I said we had two containers in the image registry, and I had specifically pulled an old one down and then forced it to be tagged as latest.
Yep.
The command that I did for that was this guy right here. So when I did my Podman pull, I pulled version 8.5-200. That's command number 1 in this history.
Mm-hmm.
And then command 2 is the Podman tag, which says create a new tag called UBI latest that's based off of UBI 85200. And that was to force it so that when I did the auto update, it would have an auto update to apply, right? By starting my whole thing on this older version of the universal base image container, I ensured that there would be an updated version available when I ran the Podman auto update. So there was a little bit of fake and bake here, but that's what it was.
Shh, we don't have to say that. All right, cool. Well, I'll ask again if folks have any questions about doing some of these OpenShift-less operations within Red Hat Enterprise Linux for maybe some simpler deployment. We stand at the ready to answer. We here, meaning Scott, not me, possibly Jafar. He'll convince you that you need to go to OpenShift.
No, what do I have to do with OpenShift, right?
All right.
All right. Great demo, Scott. Thanks.
Yeah.
And we learned new things today, so it's always good to be around.
Yep. And so again, take a look at the chat for, we dropped some links in there for more information. What we've given today is a bit of a peek into a different way of looking at deploying containers that, it's not OpenShift, wonderful as it is, might not always be the answer for certain kinds of deployments where the need, is somewhat different, right? So great demo, Scott. I'm not seeing any additional questions, so I would just again say like, subscribe, and share. We're here more Wednesday mornings than not, morning here on the Eastern US. So with that, I think we can call this a show. Join us next time. And again, like, subscribe, and share. Thanks a lot, folks.
Thank you, guys.